Welcome back. In this video we're going to be looking at indices. Indices are just another name for powers or exponents. Now if you remember, another way to write 2 times 2 times 2 would be as 2 cubed. A number times itself 3 times. The same goes if we have W times W times W times W times W. Remember, when we're writing letters, we don't need the times sign in between. Because we've got 1, 2, 3, 4, 5, we have W to the power 5. And we're going to take that knowledge and find some general rules using it. So, if we have b times b, we know that we have b squared. If we have b times b times b, we have b to the power 3, or b cubed. If we're to times b squared by b cubed, we've got b times b times b times b times b. So those two and those three. So we've got b to the power 5. 1, 2, 3, 4, 5. Another way to think of that would be to do b to the power 2 plus 3, which is b to the power 5. So if you're multiplying a power, if you're multiplying a number with a power by the same number with a power, you add the powers. It only works when it's the same thing that we're multiplying, the same units. Now, it can be any letter, it can be any number, but it has to be the same one. That gives us a general rule. A to the power m times a to the power n equals a to the power m plus n. So I'm going to give you an example of that. If we had y to the power 7 times y squared, we'd have y to the 7 plus 2, which is 9. If we had 4k to the power 4 times 4k to the power 5, we would multiply our numbers first. 4 times 4, so we have 16. We've still got k's. We've got 4 plus 5 of them, so we have 9 of them. So numbers happen as normal. Powers we add. I'm going to take that one step further. If we have t to the power 5 times t to the power minus 2, we still add the powers. So we have t to the 5 minus 2. So we have t cubed, t to the power 3. But what is that? That's actually a very useful one for us. That is called a reciprocal. T to the minus 2 can also be written as 1 over t squared. A reciprocal. If you have a minus power, you have a 1 over. So I'll just show you how that would work. If we have t to the 5 over t squared. What we've got there is t times itself 5 times divided by t twice. And if you remember, what we can do when we're doing that, because we've got the same on the top and bottom, we can cancel out, just like we did with fractions normally. So that cancels, that t cancels, leaving us with these 3 t's, t to the power 3, as we expected. So this gives us another general rule. This gives us, it actually gives us 2 general rules here. It gives us a to the m over n. Oops, sorry, I'm getting ahead of myself there. A to the m over a to the n is a to the m minus n, and it also gives us a to the minus m is the same as 1 over a to the m. Now, that's us with 3 of the rules. Rule 1, Rule 2, and Rule 3. We have 6 rules in total, and your first assessment will test 5 of them. So let's have a look at some of the others. So, just want to show you how to use that one a little bit. If we have, let's see, if we have y to the 8 over y to the 3, we have y to the 8 minus 3, which is y to the 5. If we had 9x to the 5 over 3x to the 3, we would have 9 over 3. Remember, you can do your cancelling down of your numbers separate. 3 goes into 9 3 times. So I can cancel that down. And what I have is 3x to the 5 minus 3, x squared. The same actually happens if you have numbers that are decimal or fractional. So if I had p to the 6.6 over p to the 4.8, I would actually have p to the 6.6 minus 4.8, which is 1.8. This is a handy technique because there are other methods that you can use, but this is the fastest one to get the answer. I'll give you one more example of this. If we have 8y to the 6 over 6y squared. Another way you can think of this would be 8 why did I choose y, over 6y, and you could cancel down. So we would have y's top and bottom, and we've got 8 and 6 are both even numbers, so they can cancel down to 4 and 3, giving us a final answer of 4y to the 4 over 3. This is a long way of doing it. The more practice you get, the faster you get. But if it helps to write it out the long way, there's nothing wrong with that whatsoever. Okay, so let's move swiftly on to the next rule. Consider what happens when we have x squared squared. Well, what we've got is x times x times x times x. So what we've got is 4 x's. So we get x to the power 4. If we have y cubed and square it, we have y times y times y times y times y times y, which is y 6 times. This gives us the general rule: a to the power m to the power n equals a to the power m times n. 2 times 2 is 4, 3 times 2 is 6. So when you do a power to a power, you multiply. When you do a power times a power, you add. That leads us on to one more. So I just want to remind you briefly that if we have a number divided by itself, what we actually have is 1. When you cancel them out, they don't cancel to 0, they cancel to 1. 1 over 1 is always 1. The same happens when you have a letter. So if we have x over x, we have 1. That actually gives us a general rule. For example, if we had a squared over a squared, we could use what we already know. We had a to the 2 minus 2, because when you're dividing you take away the power, which would give us a to the power 0. And anything to the power 0 is always 1. If you look, you could cancel the a squared into the a squared. Just to give you some examples of that, if I had p to the power 0, I have 1. If I have 3 to the power 0, I have 1. If I have 4x to the power 0, I have 4 times 1. So I have 4. Be aware of that. Be careful of that. The number is multiplying the 1. However, if I have 2 to the power 5 times 0, whatever 2 to the power 5 comes out at, I'm also going to have 1. If I had c to the power 8 times c to the power minus 8 to the power 4, what I actually have there is c to the 8 minus 8, which is 0, to the power 4. Which actually gives me 1 to the power 4. Now, 1 times itself, no matter how many times you do it, will always be 1. So just be a little bit wary. The only time a power 0 doesn't give you an answer of 1 is when it's multiplied by a number as well. I'm going to give you the final rule. And this one looks horrible, but with practice you get used to it. So if we had x to the power a half, what we've actually got there is the square root of x. So a fractional power tells us our root. If we had y to the power of third, we would have the third root of y. And we write that with the 3 inside the tick, not out the front, because that would make it a surd. We want it inside the tick, because that makes it the cube root of y. So that leads us to the rule a to the power m over n equals the nth root of a to the power m, which can also be written as the nth root of a all to the power m. It's the same thing, gives you the same answer, but sometimes it's easier to work out this way than it is this way. So let me give you an example of that. If we have y to the 2/3, we have the cube root of y squared. If we have the cube root of y to the 4, we could write that as y to the 4 over 3. So this is doing it backwards. Same if we had the 8th root of a to the power 5. We could write that as a to the 5/8. That is an 8. I'm going to show you another one here. If we have k to the power 4, but we're looking for the square root of it, we could write that as k to the power 4 over 2. But you know that the fraction number 4 over 2 is the same as 2 over 1, or just the number 2. So we could write that as k squared. Now to show you where that came from, let me see if I can find a pen that's a different colour. K to the 4 is the same as writing k times k times k times k. Now if you think back to the surds you were doing in the last video, we're looking for pairs. There's a pair, there's a pair. With a pair, you bring a k out the front. With the other pair, you bring the k out the front. They times together, so you have k squared, which is exactly what we've got there. 2 ways of doing the same thing. If you want more practice of them and you have the book, TJ Maths book, page 173 to 177. If you don't have a book, if you look on a Schoology website, you'll be able to access some more worksheets. Thank you.